Assalamu alaikum, dear students. I hope you all are fine. Today I am going to record this lecture of exercise 18.4. First, before going to start exercise, first we will discuss the method which is used in exercise 18.6, which is K method. K method is basically uh, their type of method which we use to solve. We use to prove or simplify the ratios. What is K method and how can we use this method? I will explain this is steps, step by step. Now, first, it may be two or three ratios. First, for example, if we have two ratios, A ratio B proportion, C ratio D is in proportion. This is in proportion form. So now by using K method, their ratio means that is divide and the proportion means equal. So A divided by B equals to C divided by D equals to K. We will let these ratios with a constant number which is K. Now A divided by B equals to C divided by D equals to K. This means that A divided by B also equals to K and C divided by D also equals to K. So we will separate this. A divided by B equals to K and C divided by D equals to K. From here A equals to BK and from here C equals to DK. This is the procedure of K method. By using this method, this procedure, we will explain, we will show, we will prove the other ratio and proportion questions. We will prove and we will show. First, before going to start exercise, I will explain the examples. In first example, we have A ratio B proportion C ratio D. Then show that 8a minus 5b divided by 8a plus 5b equals to 8c minus 5d divided by 8c plus 5d. So we have A ratio B equals to C ratio D, which is given. So from here we will change this ratio into fractional form. This means A divided by B equals to C divided by D equals to K. Yeah, we consider this ratio is equals to a constant K. From here we will find a value of A. This means A equals to BK, and from here C equals to DK. Now we will replace these values in the question, which question left and right hand side. So in left hand, first we consider its left hand side. Left hand side is 8a minus 5b divided by 8a plus 5b. In this left hand side we will replace the value of A, which is BK, and we will replace value of C, which is DK. First we will replace A means equals to BK. In place of A we will replace value of BK. Hence 8BK minus 5B divided by 8BK plus 5B equals to B into 8K minus 5 divided by B into 8K plus 5. B and B cancel each other. The remaining term is 8K minus 5 divided by 8K plus 5, which is the solution of its left hand side. Now we will simplify. We will solve its right hand side, which is 8C minus 5D divided by 8C plus 5D. In place of C, I will replace value which is DK. DK. So in 8DK minus 5D divided by 8DK plus 5D. D. Now from numerator, D is common. So by taking D common, 8K minus 5 divided by D into 8K plus 5, which means D and D cancel each other. The remaining term is 8K minus 5 divided by 8K plus 5, which is the solution of right hand side. Now see, the solution of left hand side and the solution of right hand side both are same. This means that left hand side equals to right hand side. Hence we show that left hand side and right hand side are equal to each other. This is the method to show or prove the given ratio and proportion question. Now in example 2 we have three proportion. We have three proportion. In these three proportion we will use K method and we will prove the given question. Here we have ratios A divided by B equals to C divided by D equals to E divided by F. By using K method, first we will let A divided by B equals to C divided by D equals to E divided by F equals to K. Now we will separate these terms: a divided by b equals to k, and c divided by d equals to k, and e divided by f equals to k. From first term, we will find the value of a, which is a. Here b is in division form, so we will shift this toward the other side. It become multiplied. This means a equals to bk, and from here c equals to dk, and from here e equals to fk. In left hand first, now we will start we will consider first is left hand side. In left hand side, first consider left hand side: a plus c plus e whole cube divided by b plus d plus f whole cube. In this left hand side, we will replace the values a, c, and e. In place of a, which we replace bk, and in place of c we replace dk, and in place of e we will substitute fk. Now denominator and denominator, there is no any changes in denominator, because we don't have value of b, d, and f. Now from numerator, here k is common in all these terms, so by taking k common in these all terms, the remaining term is b plus d plus f whole cube. Now this cube is on k, and this b plus d plus f also, so now we separate this cube on k, and b plus d plus f whole cube. Now b plus d plus f whole cube is in numerator, and b plus d plus f is in numerator also, so numerator and denominator cancel each other, and the k will remain. Only k cube is remaining. Now another we will consider its right hand side. Its right hand side is ace divided by bdf. We don't have value of b, d, and f. We have only value of a, c, and e. So in place of a, I will replace value of a, and which is bk, and in place of c I replace value of c, which is dk, and in place of e I replace value of e, which is fk. Now by simplifying this, these all terms there are three k's, and these all k's are multiply each other, so k multiply by k multiply by k, which is equals to k cube, and bdf remain as it is, and denominator will also remain as it is. bdf and bdf cancel each other, and the remaining part is only k cube. This is the solution of right hand side. Now the solution of left hand side is also k square k cube, and the solution of right hand side is also k cube. This means that left hand side equals to right hand side. Hence we have proved this equation or this expression. The next example, example number 3, which is if a divided by b equals to c divided by d equals to e divided by f, then show that a square plus a square plus c square plus e square into b square plus d square plus f square equals to ab plus cd plus ef whole square. We have we have to we have to show that this left hand side and right hand side are equal to each other. So first we have given that a divided by b equals to c divided by d equals to e divided by f. Now by using k method, we will let these all terms equals to k. After equating, a equals to bk, c equals to dk, and e equals to fk. These are the values of a, c, and e. Now we will consider its left hand side, and in left hand side we will replace the values of a, c, and e. We have already find. So in place of a there is bk, in place of c there is dk, and in place of e the value is fk. So a square means b square k square, c square means d square k square, e square means f square k square, and the b, d, f will remain as it is, because we don't have values of b, d, and f. Now by solving this from these all three terms, k square is common, so by taking k square common, the remaining term is b square plus d square plus f square, and here b square plus d square plus f square, these two terms are same, so it become whole square, and the solution of left hand side is k square into b square plus d square plus f square whole square. Now also solve its right hand side. Right hand side is ab plus cd plus ef whole square. Now in place of a, replace value of a, which is bk. In place of c I will replace value of c, which is dk, and in place of e I replace value of e, which is fk. Now b and b multiply with each other, it become b square. D and d multiply with each other, and it become k d square, and f multiply each other, it become f square. So k is common in these all terms. By taking common k, the remaining term is b square plus d square plus f square and whole square. So this whole square is on k, and this b square plus d square plus f square also. So by separating this square on k, it become k square into b square plus d square plus f square whole square. This is the solution of right hand side. Now see, left hand side and right hand side, solution of this left hand side and right side are equal. So hence we will show that these two equations are equal to each other. Now we are going to start exercise 18.6. I hope it is clear for all. The examples are clear for everyone. So now we are going to start exercise 18.6. First, in exercise 18.6, question number 1, bit number 1. In question number 1, we have given that P ratio Q equals to R ratio S. We have to show that 8P minus 3Q divided by 8P plus 3Q equals to 8R minus 3S divided by 8R plus 3S. By using K method on this ratio, on this proportion, we will show that this left hand side and right hand side are equals to each other. So by using K method here, P upon Q equals to this, we will convert this ratio into division form. So P upon Q equals to R upon S equals to K. First we let that this equals to K. Now by separately we will separate this P upon Q equals to K and R upon S equals to K. From here P equals to Q is in division form, so when we shift this Q towards another side, it become multiply with K. Hence P equals to QK and R equals to SK. We find P and R. Now by replacing these values, we will prove the given question. First we consider its left hand side, which is 8P minus 3Q divided by 8P plus 3Q. Here we will replace in place of P, which is its value, which is QK. In place of P, I will put QK and it become 8QK minus 3Q. I can Q come as it is because we don't have any value of Q. So in denominator here is P. In place of P, I replace QK, 8QK plus 3Q. From numerator, I am taking the common Q because Q is common in both. So the term remaining is 8K minus 3, and denominator also Q is common. So by taking Q common, the remaining term is 8K plus 3. So the remaining term become 8K minus 3 divided by 8K plus 3. This is the solution of left hand side. Now we will start right hand side. Right hand side is 8R minus 3S divided by 8R plus 3S. Already by using K method, we have find the value of R, which is SK. Now replace R, the value of R, which is SK. So this equation become 8SK minus 3S divided by 8XK plus 3S. In place of R, I replace SK. Now in numerator, there is S is common in both terms. So by taking S common, the remaining term become 8K minus 3. In denominator also S is common, so the term remaining is 8K plus 3. Now S and S cancel each other, so it become 8K minus 3 divided by 8K plus 3, which is the solution of right hand side. Now check the solution of left hand side and the solution of right hand side is same. So left hand side equals to right hand side, which we have to solve. Hence we have shown that left hand side and right hand side are equals to each other. I hope this question is clear for everyone. Now there is another question, which is bit number 3. Question number 1, bit number 3. Here P square plus Q square ratio P cube divided by P plus Q equals to R square plus S square ratio R cube divided by R plus S. We have to prove, we have to show that left hand side and right hand side are equals to each other. First I consider its left hand side, which is P square plus Q square ratio P cube divided by P plus Q. In this we have already find the by using K method, where P equals to QK and R equals to SK. So in place of P, I replace QK in left hand side. So in the place of P, I replace QK whole square plus Q square divided by change this ratio in just division form. QK whole cube divided by, in place of P, I replace QK plus Q. Here this square is on Q and K also. So I separate this q square plus q square k square plus q square, and we have to change this division into multiply. It become reciprocal. Reciprocal means numerator become denominator and denominator become numerator. So divide change into multiplication, and this numerator change into numerator. Qk plus q divided by, here this cube is on q and k also, so I separate this cube on both terms to then q cube k cube. Next, from here, their q square is common in these two terms. So by taking q square common, here the remaining term is k square plus 1. And from this term q is common. So by taking q common, the remaining term is k plus 1 divided by q cube and k cube as it is. Now here k is q square. From q square in denominator q cube, and q square and q multiply. When we multiply these two terms, it becomes q cube. In numerator there is q cube, and in denominator there is also q cube. So these two q cubes are cancel each other, and the remaining term here k square plus 1, and which multiply with k plus 1, and in denominator there is k cube. This is the solution of left hand side. Now we will solve also its right hand side. Here this is our right hand side is r square plus s square equals to r cube divided by ratio r cube divided by r plus s. In place of r, I will replace its value, which is sk. So by replacing value of r, sk whole square plus s square divided by r cube, which is sk divided by sk plus s. Now this square is on s and k both, so it become s square k square, and in this there is also s square, and here also s square. So by s square is common in both terms. So by taking s square common, the remaining term is k square, plus here we will take already s square common, so the remaining term is 1. Now there is in division divide, we will change divide into multiplying by change into multiply by reciprocal, by taking reciprocal. So in denominator become numerator, numerator become denominator. Now in this term s is common, so by taking s common, here k we will take s common, so the remaining term is 1. So s into k plus 1 divided by, here s cube k cube. Cube is on s and k both, so separate this cube on s and k, so it become s cube and k cube. Now s square and s both are in numerator, so s square and s become s cube. S cube is in denominator also, so s cube numerator and denominator cancel each other. Then the remaining term is k square plus 1 into k square k plus 1 divided by k cube, which is the solution of right hand side. And this is also same as left. This is all, and the solution of left hand side is also same as solution of left hand side. Right hand side and left hand side, the solution of both sides are same or equal. Hence we have shown that the given equation left hand side and right hand side are equal to each other. The next question, which is bit number 5, question number 1, bit number 5. Here we have p minus q divided by p ratio q divided by p plus q equals to r minus s divided by r ratio s divided by r plus s. First we will consider its left hand side. Here in left hand side is p minus q divided by p ratio q divided by p plus q. We have already find the, by using k method,